All right, greetings everyone. Welcome to the first part of the video for section 4.5. Continuing with our study of logarithms, and now we'll be looking at the graphs of logarithmic functions. So we're going to start by analyzing the graph of the function g of x equals log of x, and notice that here we're just using the common log, so this is like the log base 10. And this will kind of give us a basic idea of what most graphs of logs will look like. And also I would say, in general in this class, the graphs, the log graphs we're most concerned with are log base 10. So we're going to graph this and we're going to identify all of these things over here. So vertical and horizontal intercepts, domain and range, and any asymptotes we see. So let's take a look at this. So we'll go, first of all, make sure. We'll go to our graphing calculator here. We'll hit this y equals. We'll put in log of x as the function we're going to graph. And we'll go ahead and graph it. Make sure we're in, and I'm not. We're going to do a 10 by 10 window. So let's do zoom 6. And in the graph here, it kind of looks like the graph stops here at an output of -1, but it actually continues on. Not like that, though. It continues on kind of like this. Okay, going right along that vertical axis there. Okay, so let's look for any intercepts. And as I just kind of gave away, it's going along the vertical axis, so it doesn't actually intersect the vertical axis. But notice it does intersect the horizontal axis. So we see a horizontal intercept there at the point 1, 0. For the domain here, well, again, it looks like we kind of get stopped at the vertical axis here, but then all other input values to the right seem to be okay. So it looks like our domain here is going to start at 0 but not include 0 and go up to positive infinity. And then for the range, when you look at this function, it can look like there's some sort of a horizontal asymptote here, maybe like something like that the values are getting closer and closer to. But if we go to our table and start to increase our input values, you should notice, looking at the output values, that they're going up. They're just going up very, very slowly, right? And in fact, if I change where my table starts, like say I make it start at 1,000 rather than at 0. Okay, well notice at 1,000, the outputs have only grown to 3, and they're continuing to grow from there. So what we see is that this function continues to grow bigger and bigger and bigger, just very, very slowly. So what that tells us about the range is there's actually no bound on it. And so our range is going from -infinity up to positive infinity. And then for asymptotes, well, we just saw there were no horizontal asymptotes, but it did look like there was a vertical asymptote. Right? Vertical asymptote. And here it looks like, in this case, that vertical asymptote is at x equals 0, because it's right there along that vertical axis. Also notice that here, the function being not transformed in comparison to that vertical axis, we see the graph shooting off to the right. Okay, and so that's going to be important later on when we talk about transformed log functions. Okay. All right, so going back to our PowerPoint then, let's look at a slide that just kind of summarizes this information. And notice here that they talk about the graph of log base b. So the base could be anything. But regardless of what the base is, we see these same things for the graph of the function log base b. So first of all, it's a horizontal intercept at 1, 0. Vertical intercept at, vertical asymptote at x equals 0, whatever the input variable is equals 0. We saw that the graph was increasing. I also didn't mention it's concave down. The domain is 0 to infinity, and the range is negative infinity to positive infinity. All right. So moving on from there, let's talk about finding the domain of logarithms. So here we have this function f of x equals 5 plus ln of 4 minus 3x. And notice the domain, or remember the domain has to do with the input values of the function. So all the possible values we can have for x here. And notice first of all, to figure that out, this 5 on the outside, we don't really need to worry about that. That's not going to have any impact on what goes on with the x value there. And notice that the x is inside of a logarithm, right? Well, we just saw the domain of something like log of x. Domain there, the values for x had to be anything basically bigger than 0, right? So what that tells us is that what's inside of our log there, 4 minus 3x, that has to be bigger than 0, right? And notice it can't be equal to 0 because we have a parenthesis over here. So I'm going to go ahead and solve that inequality. So subtract 4 on both sides. So we'll end up with minus 3x is greater than negative 4. And we can divide by negative 3 on both sides. We're dividing by a negative, so remember that'll switch our inequality. So this will become x is now less than negative 4 over negative 3, or just 4/3. If we now write that in interval notation, since we're talking about values less than negative 4/3, this is going to be negative infinity up to 4/3, close parentheses. Okay, and that would be our domain. Now notice that domain includes negative numbers, right? It's numbers less than 4/3. So we could have like -1, -2. And that might sound a little contradictory based on what I just said. Remember, it's what we get from this. So whatever this expression is equal to right here, this 4 minus 3x, that cannot be negative. So we can plug in negative values there. For example, if we plug in -1, we'll get something that's okay. All right, that's it for now. Thank you for watching.